The next test is called logarithmic test. So in this lecture, we discuss about logarithmic test. Let sum of un with a series of positive terms such that limit of n log un upon un plus 1 when n tending to infinity, which is equal to L, then the series sum of un is convergent if L is greater than 1, divergent if L is less than 1, and test fails if L equal to 1. Now we use this test, so clearly this test is applicable when the ratio test fails. Okay, but we have already seen that if the ratio test fails, then we can also apply the Robbins test. But logarithmic test is applied in those series where the nth term has some power. Nth term of the given series has some power. Then we use the log of the reducing the power of the nth term. Let us take one example, then it will be very clear what is the logarithmic test. Test the convergence of the series sum of 1 square plus into 5 square into 9 square up to 4n minus 3 whole square upon 4 square into 8 square into 12 square up to 4n whole square. The given series is sum of 1 square into 5 square into 9 square up to 4n minus 3 whole square upon 4 square into 8 square into 12 square up to 4n whole square, which can be expressed as 1 by 4 whole square plus 1 into 5 upon 4 into 8 whole square plus 1 into 5 into 9 upon 4 into 8 into 12 whole square. And the nth term of the series will be this 1 square, or we can write down 1 into 5 into 9 into 4 and minus 3 whole square, divided by 4 into 8 into 12 into 4n, and this whole square. So if we compare this series with the general series, the un is given by 1 into 5 into 9 up to 4n minus 3 upon 4 into 8 into 12 into 4n whole square. So now since here the un has its power 2, therefore first we apply the ratio test, and then we apply the logarithmic test if the ratio test will fail. And let us write down un plus 1. So we have to add one more thing. This n is replaced by n plus 1. So this is the n plus 1 term. So 4n plus 4 minus 1 is 4n minus 4n plus 3, not minus 3. And divided by 4n plus 4. Consider ratio of un upon un plus 1 when n tending to infinity. This is un divided by un plus 3 upon 4n plus 4, 4n plus 3 upon 4n plus 4 whole square into un. This un cancel, and this will be reverted in 4n plus 4 whole square, 4n plus 4 upon 4n plus 3 whole square. And if we take n square outside from the numerator as well as denominator, this will become n square into 4 plus 4 upon n whole square divided by n square 4 plus 3 upon n whole square. N square will cancel. And if you put limit over here, 4 upon infinity is 0, 3 upon infinity is 0. So we are getting 4 upon 4, which is 1 square, and which is nothing but 1. Here, the ratio of un upon un plus 1 when n tending to infinity, which is equal to 1. Hence, ratio test failed over here. Now, so it is not possible to say about the convergence or divergence of the given series using the ratio test. So now we can apply, again look here, the nth term has power 2. So instead of using the Robbins test, we apply the logarithmic test. So let us consider, we have to check the convergence of the given series by using logarithmic test. We first consider log of un upon un plus 1. And un upon un plus 1 is nothing but 4n plus 4 upon 4n minus, this is plus, not minus, 4n plus 3 whole square. And this power log of m to the power n is m log n. So 2 log 4n plus 4 upon 4n minus 3. Since log 1 plus x is equal to this, we know about this expression. So we can write down 2 log 4n into 1 plus 1 upon n divided by 4n 1 minus 3 upon 4n. Actually, it is always positive. Okay. So this 4n and 4n will cancel. And this is 2 log 1 plus 1 upon n minus log 1 plus 3 upon 4n. And if we write down the expression, now this expression is okay, right? 1 upon n, using this formula, 1 upon n minus 1 upon 2n square plus 1 upon 3 n cube up to and so on, minus 3 upon 4n minus 3, 9 upon 2, 4 square n square plus 27 upon 3 into 4 cube n cube. And if we simplify this, 1 by n we are taking outside, so 1 minus 3 by 4, first term of both the series. If we take 1 upon 2n square outside, here 1 is remaining, and here 9 upon 16 is remaining because we have taken 2n square outside. Similarly, if we take 1 upon Similarly, we take 1 upon 3 into 1 upon n cube. Then the 1 minus 27 upon 64 will be remaining. Okay, let us try to simplify it. Two times of this, if we simplify it, 4 minus 3 is 1 upon 4, so 1 by 4n. Similarly, 1 upon 2, 1 upon 2n square. 16 minus 9 is 7 upon 32 of n square. Similarly, 64 minus 27 is 37 divided by 3 into 64, which is 192 n cube, and so on. This is the value of log un upon un plus 1. We can take 1 upon 2 and let us multiply this by this 2. So 2 1s are 2 2s are 4. So 1 upon 2n minus 7 upon 16n square plus 37 upon 96 n cube, and so on. Therefore, n log un upon un plus 1 is multiplied this term by n. This n will cancel, 1n will cancel, 1n will cancel. And now, if we see it, it is 1 upon 2 minus 7 upon 16n plus 37 upon 96 n square, and so on. So this is the what? This is the value of n log un upon un plus 1. Let us try to find out its limit, because we have to check the convergence of the given series by using logarithmic test. Now consider limit of n log un upon un plus 1, which is equal to limit of 1 upon 2 minus 7 upon 16n plus 37 upon 96 n square, and so on, when n tending to infinity. So if you put n tending to infinity, this will become in some 7 upon infinity, 37 upon infinity, and all the remaining term will be something upon infinity. So this will become 0, and we have only one value, which is nothing by 1 by 2. And since 1 by 2 is less than 1, hence by the logarithmic test, the given series is divergent. Thank you.